In this video, we're going to graph the reciprocal function y equals 1 over x squared minus 6x plus 8. Okay, well, in order to do that, we'll begin by graphing the function y equals x squared minus 6x plus 8. We can factor, and when we do that, we see that we've got a vertical asymptote at x equals 4 and a vertical asymptote at x equals 2. Also, we can see that our axis of symmetry is going to be halfway in between those numbers. So we can add them and divide by 2 and we get 3. Determining the y value, we get, plugging in 3 to our expression for y, we get -1. So we have a vertex at 3, -1, and vertical asymptotes at 4 and 2, and we get a curve that looks like that. Now our first step is to draw in the vertical asymptotes at every x-intercept, so we do that. So now what we're going to do is we're going to go to each point that has a y-coordinate of 1, and each point that has a y-coordinate of -1. And we see the vertex has that. So on the upper left, we see that our curve is going to go it's going to treat the x-axis as a horizontal asymptote and treat each of these vertical asymptotes the way it should. Now in the in-between part, we see that we have the function y equals x squared minus 6x plus 8 has a minimum at the point 3, -1. Well, now, if I put a 1 over that x squared minus 6x plus 8, then that means as that value of x squared minus 6x plus 8 gets bigger, 1 over it gets smaller, and vice versa. So putting a 1 over it changes the word minimum to maximum. The x value of 3 stays the same, but the y value is 1 over -1. Well, 1 over -1, that's just the same as -1. So the maximum doesn't change, but we see, the y-coordinate doesn't change, but we see that it's now a maximum at that. So we've got a maximum at the vertex indicated in red there, and we see that as the parabola goes up to the left, our curve should go down to the left, but treat the vertical asymptote like a vertical asymptote. And as the parabola goes up to the right, our curve that we're actually drawing should go down to the right, treating the vertical asymptote the way it should. And so that's the curve that we end up with. We see that our domain is going to be the set of all x element of the reals such that x cannot equal 2 or 4. Our range is going to be the set of all y element of the reals such that y is less than or equal to -1. Okay, that's that point right there. Y is less than or equal to that. Now, y cannot be anywhere in this interval between -1 and 0. So there's a blank space there, and then we pick it up again greater than 0, but it can't equal 0 because y equals 0 is a horizontal asymptote. So there's our range. Now our increasing interval is all x's that are elements of the interval from -infinity to 2 in union with the interval from 2 to 3. We see here we're going up as we move to the right in that lower portion there, the part that I've sort of bolded in. You're not looking at the direction of the arrow here. That's not what you're looking at. Now, there's a way of thinking that I adhere to, which says we should actually include the 3 in the increasing interval. Your textbook doesn't, so it's okay to me either way how you put it. Our decreasing intervals, they're going to be any x value in between, in the interval from 3 to 4 in union with any x value from 4 out to infinity, or the same school of thought would say put a square bracket on the 4, and that's actually how I think it should be done. but either one of those two answers for decreasing interval would be correct. Our positive interval, we see the two portions above the x-axis are the portions where x is anywhere between negative infinity and 2 in union with 4 to infinity. And then our negative interval is the portion in between 2 and 4. So x is an element from the interval from 2 to 4. And finally, our horizontal asymptote is at y equals 0. And our vertical asymptotes are at x equals 2 and x equals 4.